While protecting the planet takes up much of John Rommel's time, the rest of his working day is spent making sure we don't contaminate other planets. Any probe sent to Mars or Europa has to be spotless.
There's a test before they can launch, and the Planetary Protection Officer is responsible for providing that test. And we go down and we assay the spacecraft for the presence of microbes, and they get a passing grade or a failing grade.
But you'd be able to cancel the mission?
Yeah. I would have the authority to say stop. More likely I would say clean it first, then you can launch it.
We have main engine start, 0, and liftoff of the Stardust spacecraft, returning a time capsule with the elements of the formation of our solar system.
If the panspermia theory is to be proven one way or the other, it's vital not to contaminate other planets.
Got solid motor jettison, all 4 solids came off.
If we go to other moons, other worlds, etc., and take Earth contamination there, and then later go back and discover life and go, golly, life on Mars looks just like life from Florida. How about that? We're actually ruining the principal element that NASA focuses on, as preserving the science.
Things look very good at this point. Going just under 5,000 miles an hour.
You guys ready?
The greater the likelihood of finding life, the stricter the cleanliness required. Deptex will have to be spotless for her voyage to Europa. But sneezing into the machine is the least of Bill Stone's problems at the moment.
You ever hear that Dirty Harry line? Do you feel lucky? In this case, we ask everybody, did you check all the O-rings?
Instead of sending Deptex all the way to Europa on her maiden voyage, they're going to lower her into a tank of water on the other side of the workshop. And even here, there's still much to go wrong, not least to find out whether this $5 million submarine is waterproof.
Okay, and I've got 2 connectors over here, 2 MiG-10s that are open.
Let's just vent it all the way. Yeah, let's just vent it all the way. Right, just to the surface. Okay, lower. All right. Southwest Research, and the CU's wet. No leaks. No leaks so far. This is a big step going wet.
While Bill and his team continue their hunt for alien life in the solar system, panspermians are waiting for the party to come here, hidden amongst some of the 500 tons of meteorite that fall to Earth every year. One particularly rare type of meteorite is the carbonaceous chondrite, a sort of burnt-out comet. Some believe that this is the most comfortable form of transport for an alien visitor. And Richard B. Hoover is convinced he's found the evidence of just such an intergalactic joyride. It's called the Murchison meteorite, and it fell into the Australian outback.
One lady was hanging up her laundry, and she saw the sun in the sky, and she thought it was strange because it was in the wrong part of the sky. And then she looked and saw that the sun was in the right part of the sky, and here were 2 suns. And she was actually seeing the fireball associated with the Murchison meteorite when it came in. And large chunks of Murchison black rock landed all around her. One piece actually came smashing through the roof of a shed. In fact, this is one of the pieces of Murchison that fell. And in fact, when you open the vial, you can actually get a bit of the aroma, the odor of the Murchison meteorite. And it has a tarry, sulfurous smell. It's really quite spectacular. These are the organic gases that are still continuing to come off of the meteorite. We take the meteorite and we break it in a fresh fracture and then put it under the electron microscope so that we look at a freshly broken piece of the meteorite. And we found a lot of very, very complex structures that look like microfossils of blue-green algae, not just in terms of shape, but also in terms of precise detail in structures like reproductive structures and the presence of external structures as well.
You found evidence of life.
Well, I think it's tremendously interesting that the meteorites appear to contain the remains of living organisms. I think that these living organisms were actually living on a body like a comet. If, in fact, this is correct, this means that comets may be carriers of life from one place of the solar system to another.
He's found fossils, entire colonies of fossil microorganisms just stuck in the middle of these space rocks.
It's amazing.
I think it is amazing. I think it really proves that comets were the carriers of life, are still the carriers of life. And when a comet becomes exhausted, when all the gases flow out of them, then these fossils remain, and that's what he's finding.
Richard's claim that this is fossilized life is highly contentious, and it still leaves open the question as to whether life forms on a meteorite could survive the dramatic impact of landing on Earth. They say it's not the falling that kills you, but the sudden stop at the end.
What Mike is doing today is he's taking small grains of rock which have bugs in and then putting them into a missile, a carrier which will be launched in the gun, and the grains of rock carry on and hit the target. The bug is sitting in a rock. It lives in the rock and is quite happy there as bugs go. But in our case, that bug is suddenly going to be accelerated.
At the University of Kent, they're trying to replicate what happens to the bugs when they crash into Earth on the back of a meteorite. For this, they need a very big gun and some very small bugs. Oh, and a belief in panspermia.
So what will happen next is we fire the gun, and we want to reach a speed of 5 kilometers a second. That's about 10 to 15,000 miles per hour. So it's going to be fast. The target is water with a rock behind it. So it's like hitting an ocean, where first you have the water, and then there's an ocean floor beneath it. They will hit the water as if they've come from space at these 10, 20,000 miles per hour, and the bugs will be very heavily shocked, and this would normally kill most things. The only question is, will it survive? And if it does, it will just be happy again, growing in its new home.
The firing of the gun happens in a vacuum to maximize the speed. The bugs are now on a 15,000 mile per hour roller coaster. And remember, in space, no one can hear you scream. Have any of the bugs survived?
And I'm afraid nothing's hit the target. The rock has come off slightly off axis, and instead of going through the hole here, has hit the container up here, so our target's still intact, and our bugs have hit solid metal, and that's a lot harder than water when you hit it at high speed, and so they've probably been crushed and almost certainly all dead. So, hey-ho, it's a bug's life.
But other experiments by Mark have confirmed that bugs can survive. These are some of the lucky ones. The casualty rate is very high, but this is not a problem.
What would happen is if you went into the garden and dug up 1 gram of soil, 1 little small cubic centimetre perhaps of soil, you'd find 10 or 100 million bugs in there. If we could fire a rock that size in our gun, with that number of bugs in, we would find about 10 or 100 of them survive our experiments. So the survival rate is very, very low. But you only need 10 or 100, and they just multiply. About 5 or 6 years ago, when I went to the first meeting and announced this work, we were still doing tests and didn't have success, but someone in the audience just stood up and said, "This is crazy, why are you doing this? Everyone knows the answer, nothing survives." Well, we then did some more experiments. We started to show that in high-speed impacts, bugs can survive, and potentially could have come from space if they were out there, and invaded the Earth, as it were. At which stage, when we started announcing the results in conference, a different person stood up in the audience and said, "Well, why are you doing these experiments? Everyone knows the answer. Of course they survive." So in the space of just a few years, it went from being a denouncement to why are you wasting our time? Because of course it's trivial.
It's not trivial by any means, because Mark's experiments have helped to support panspermia. And it's not just been experiments in the lab that have verified the concept.
Columbia, Houston, UHF com check.
A tragic real-life event has added support to the idea. In 2003, the Columbia Space Shuttle blew up during re-entry, and 7 astronauts lost their lives. What is not well known is that some of the microorganisms on board the Space Shuttle survived.
Columbia, was a mission that effectively broke up over a multi-state area. And inside of some of those pieces, were experiments that have been flown for biological purposes. And in at least one of those experiments, the organisms survived the trip. So the Columbia accident was a tragedy that involved not only the melting of a wing, but the physical dismantling of a shuttle. It's a very interesting, fact that things falling from high up on the Earth can survive.
All scientists now agree that microorganisms can survive extraordinary conditions, be it radiation, extreme cold, extreme heat, extreme impacts. Most space scientists also believe that the solar system almost certainly contains other life forms and are very, very keen to find them. And a few scientists are convinced that certain meteorites contain the remains of life. Putting all the evidence together, Chandra believes that this is how life on Earth began in the first place. It arrived on the back of a comet 3.8 billion years ago.
Life did not start here on the Earth. We came in ready, packaged, genetic bits and pieces from space.
Other scientists disagree. They think life started here on Earth. One scientist who argues that it all began here in a small bubbly puddle is David Deamer.
If you never thought about it, if this is the first time you ever saw a soap bubble, you'd be astonished that this kind of a structure could just appear out of nowhere.
David is not blowing bubbles just for fun. He's interested in how soap bubbles, by assembling themselves, will help explain the origin of life.
So this is what we mean by a self-assembly process. It's one of the very simplest self-assembly processes.
He's using his expertise in bubble blowing to try to create new life in the lab.
It's alive! It's alive! It's alive! It's alive! Oh, in the name of God! Now I know what it feels like to be God!
David uses soapy material to form microscopic bubbles. This froth is what David believes was the first step in the origin of life on Earth. No comet required. The bubbles, or vesicles as he calls them, are crucial to his theory because they provide the perfect place for making new life from scratch.
So we think that vesicles were very much part of the first forms of cellular life. All life today is cellular. It means there's a membrane surrounding a compartment. And what we're doing here is stepping through the evolutionary process that must have occurred on the Earth about 3.5 billion years ago when the first forms of cellular life appeared.
David then inserts small chunks of DNA inside his artificial cells.
Is it alive? Not yet. But it's a shared goal of a number of laboratories now to actually make an artificial form of life.
And some might say a dangerous goal.
I don't think so. The fact is that there are all sorts of dangerous life out there right now, the latest being the avian flu virus, for example. And what we might do in the laboratory would not stand a chance of surviving, I think, in today's biological world. We think, however, that we're trying to do something that simulates what happened on the early Earth, and not trying to put together a living being in the sense that Frankenstein was.
I think they're playing it good. I think the object of all these experiments is to show that life is not that special a system. I would be exceedingly surprised if he succeeded, or if anybody succeeded, because the improbabilities are so immense, and to think that they could be overcome in a small laboratory flask is asking not for the moon, it's asking for the cosmos.
David Deamer is the first to admit that his cells are not fully fledged living organisms. But if he does succeed in creating life relatively easily, then it makes it much more credible that life could have started on Earth.
I'm always attracted to what we call Occam's razor. Look for the simplest explanation. And the simplest explanation is that there was a set of organic molecules which could self-assemble into microscopic structures that increasingly took on the properties of life as we know it. So, to sum up, life began on the Earth and was not delivered to the Earth.
We still don't know how life began on Earth. We don't know how life would have begun on other places in the cosmos, even though it's generally accepted that life began on Earth through these primordial reactions in the ancient oceans. It's quite possible that life began on Earth as a result of transfer of biological materials from other portions of the solar system.
It's these arguments that make Chandra so determined to get to the bottom of the red rain. If the red cells really are alien life, then it must be proof of panspermia. Chandra has been doing independent tests on samples of the red rain. In science, things are rarely clear-cut, and he has very different results from Godfrey.
And these are positive amplification products. Right, so this is DNA from the red rain.
Wow, there's no doubt about it.
There's no doubt about it.
It's absolutely conclusive as far as I can see.
The discovery of DNA in the red rain cells has been corroborated by another lab. Yet this recent finding has done nothing to dent Chandra's unshakable belief that the red rain is extraterrestrial. He believes that all life in the cosmos will probably share various types of DNA.
Before I came, I had grave doubts as to whether the red rain was really an indication of life coming from space, a new life coming from space. But on reflection and after talking to Godfrey, I think I would now fairly firmly believe that it did represent an invasion of microbes from space.
Over in Washington, D.C., the Planetary Protection Officer remains skeptical. He thinks the red rain has a more mundane origin.
The material examined by astrophysicists and people who are looking for evidence to support a view doesn't appear to be anything that they've ever seen before. The people who actually have seen things before say, looks like red algae to me. I would tend to go with the people who have seen more things in the biological kingdom rather than those who are looking to support their own ideas about how the world should work without the data to back it up.
For the moment, the jury's out. But Chandra remains convinced that this sort of interplanetary transfer of microbes is how life first originated on Earth. And Chandra is not alone. there are an increasing number of scientists who are happy to put their family ancestry down to aliens.
Earth life is essentially alien life. It is not a life that was indigenous to the Earth by any means. And if we evolve from that life, then I think we are the products of evolution from alien life.
If the hypothesis is correct, then all of the life that we see today originated from material that was brought into our planet. And if it's coming from beyond the atmosphere, then it is extraterrestrial. That's not an unusual concept. That's the way in which life propagates on Earth. You have seeds, and these seeds are carried by the winds, and they start growing at other places when they find conditions are suitable.
In that sense, we are all extraterrestrials. The ancestors are probably outside Earth. So we have actually emerged from some extraterrestrial organism actually.
Panspermia, the idea that life comes from space, only actually tells you how life started on Earth. It still doesn't address the big question, how did life itself start? But at least it starts giving us an answer to what's it like here on Earth, why is there life here on Earth, and it would suggest there's life elsewhere, which is something else a lot of people want to know one way or the other. Maybe we are Martians. Maybe life here on Earth came from Mars.
Much of Chandra's work on panspermia has now been vindicated. So are we really descended from aliens? It could have come straight from a comic book.
I think science fiction is always a very appealing thing for many of us to read, but sometimes science fiction turns into science fact. But the journey towards the truth is always a rewarding one, I think, and I saw this as a journey towards discovering a truth that was quite plain to me, and is becoming plainer and plainer to other people now, after 30-odd years.
If you want an experience of being humbled, go look at the NASA Hubble Deep Space image that looked into the darkest little tiny segment of the sky. And what they saw back in that picture, to me, was the most devastating news of all for people who think we're important.